Hello students, I hope you all are doing well. So today the topic of our discussion is E1 and E2 reaction. E1 and E2 reaction. These are the elimination reaction. Elimination reaction. So let's start with E1 mechanism. E1 mechanism. So this is a two-step reaction. Two-step reaction, and it is a first order reaction. Why first order? Because the rate of reaction only on depend on this substrate, which is alkyl halide. Rate only depends on alkyl halide, which is substrate. So let us see the mechanism of this reaction. So here uh, we can take any alkyl halide. Here is CS3, CS3, here is CS3. So this first step is reversible step, which is a slow step, and this one is rate determining step. So first it will form a carbocation here, like a SN1 reaction. Carbocation will form. Then again the any nucleophile will attack here in second step. Like we can take any nucleophile like OH minus, which will remove this one of the hydrogen from this methyl group, this hydrogen, and it will give us a double bond, which is isobutylene and H2O. This is the mechanism of E1 reaction. So, so here the dehydration of alcohol is also a E1. Uh, it gone through E1 mechanism. Like if I take any alcohol and H2SO4, it will give us butylene. But before it will form a carbocation. Then it will give us butylene. So it follow also E1 mechanism. Then we will see uh, reactivity of alkyl halide. Reactivity of alkyl halides, like we have seen in SN1 reaction, where like tertiary this hydrocarbon uh, will give fastest, and SN1 reaction rate of reaction will be high for 3 degree carbocation, then 2 degree, then 1 degree. So it will follow the same like SN1 reaction. Like if we have any benzylic carbocation, and it will equal to 3 degree allylic carbocation, it will give the highest rate of reaction. Then 2 degree benzylic, same like 1 degree benzylic, And again we can say that simple carbocation, which is 3-degree carbocation, then 2 degree, then 1 degree. So this will give, this is the order of rate of reaction. So as we can see the formation of carbocation here, so it will also uh, form a rearrangement product. Rearrangement is also possible here. We can understand by taking an example. CS3, CS3, then any methyl we can touch here, then halide. So if I take a base and alcohol, so here uh, it will form a carbocation. It will remove this bromine from here, then it will form a carbocation. So here we can see the shifting of carbocation here. We can rearrange this and we can make it more stable. This methyl will shift here. It will give us something product like this, CS3 and CS3. Now it is a stable carbocation and now it will give us a alkene. CS3 and CS3. So it is the final major product. Now we will see the effect of leaving group. Uh, Effect of leaving group leaving group. So good leaving group will increase the rate of reaction. Good leaving group, like it follow this order: iodine, bromine, and chlorine, fluorine. So these are the good leaving group. Another is stereo specific and stereo selective. Stereo specific and stereo selective. So it is not stereo specific because uh, the removal of proton from beta carbon atom by base is not specific, but it is stereo selective. Why? Because uh, this will form the ZF elimination product in the uh, is predominantly formed. Okay, so it will form ZF product predominantly. So that is why it is stereo selective. If we talk about solvent effect, then polar protic solvent will enhance the rate of reaction. Polar protic solvent like H2O and alcohol, any alcohol. These are the polar protic solvent. So now we will see that how to differentiate between SN1 and E1 reaction. SN1 and E1 reaction. It is a very important part. So at lower temperature, it favor SN1 reaction. Lower temperature. But at higher temperature, it will favor E1 reaction. Other one is like if nucleophiles are like uh, chlorine, bromine, and iodine. Then it tends to dominate SN1 reaction. If nucleophiles are like TSO minus, S2, PO4 minus, HSO4 minus, so this will follow even reaction. And we have to also add here heat. Here we can also add aqueous KOH or any base. Here we can add alcoholic KOH. So it will give us an even reaction, alcoholic part. So now let's solve some question which will make strong our concept. So here we have taken a base which is a nucleophile CH3O minus. So here is this substrate. So which one is good leaving group? More good leaving group. Which will leave first? It is a iodine. So it will leave first here from here. So it will give us a alkene. So we will make here a double bond. It is a chlorine. Now we have tertiary butoxide, which is a bulky nucleophile. So it can remove hydrogen from here or from here. So where is less steric hindrance? It is this side. So it will remove hydrogen from this side. So it will give us a this type of alkene, less steric hindrance side. So it is called Hoffman product. And the second one is uh, this one is there is a again there is a nucleophile which is less bulky. So it it can remove hydrogen from this side as well, which will give us a major product, and this is called self product. Self product. This is a major product. Now we have here an H2SO4 which will act as a nucleophile. It will give hydrogen this to this and it will form a carbocation. Now we have seen an example in previous slide that this carbocation will rearrange and this methyl group shift on this carbon and it will give us this type of uh, uh, a hydrocarbon. So it will remove hydrogen from this side and it will give us a alkene, stable alkene. So this will be a major product because there are 3 and 3 2, 2 there are 10 alpha hydrogen. So that is why this is a stable alkene. So I hope it will be. So I hope this may have been helpful for you. So thank you for watching. We will meet in next class.